Alright, so let's get to the client. So let's open up the client here. Alright, so the client, you either create it as a listener thread or a sender. So you either have a listener or a sender. And the way you do that is to, at one point, either create a listener thread or a sender thread. So in the constructor of a client, towards the end of it, you have start sender thread or you have start listener thread. And that's really just kind of creating a new object, and here it is right here. Create a new thread and then start it, right? And that's fine because you're only gonna you create one sender per connection to another client. But by client here, I mean like you're connecting to another client object, right? So you're crossing a NAT, or you may not be crossing that. I mean, it would still work if you're not behind NAT, but you're connecting to another client that's using this API, in connecting to the same server as you. So you have three constructors. Two of them, the first two, are for listeners. So it's kind of like a server socket. It's like the Java server socket, right? And then you have the third one, which is like a Java socket, and that's just your sender, right? So you have your sender, and then you have your two different versions of receivers. For all of them, you need to have the server address and the server port. Once you have that, the rest of it kind of determines what you're doing. You could have a listener port, or you can give it the des address and destination port. So it'll do a lookup on the address. You don't have to use an IP address. You could use like a normal URL or whatever. Yeah, in any case, you create one of the two, and then you connect to the server, because both the sender and receivers need to connect to the server first, which involves a back and forth between them, just to make sure that they're connected. And once you're connected to the server, I mean, there's two different versions. One is you have you can determine what the local end of your port, with the local port of it, like the local end of your socket, what the port is going to be. So you have this, but not a big distinction there. Then you either start a sender or thread, or start a listener thread, right? Or I guess you already did that. So if you're a sender or a listener, you're still going to connect to the server. Yeah, then there's just some other stuff here. This is really for the interface that we have, which is here. It's very simple. Basically this and this are the most important parts of it. So you can send and receive data, and this just kind of provide for convenience, I guess. It's just really nice to be able to just write a string literal and just have it, all the work be done for you. Alright, so listener and sender. Listener just kind of waits for commands. It gets a string and then it parses it, and if it's connect, it sends a connect accept. If it's data, then it kind of just receives it, right? And what it does with it is up to whoever's using that client listener, because you can read from the client listener, right? Because you can get the string directly. So that's it. So for sender, you're sending, so you have to connect first, right? So you send a connect message and you try to get a connect accept message back, and that lets you know that you connected to that other peer, or that other host that's running this. That has a client object that's listening. If that client isn't there, or if that other host isn't there on your little network, quote unquote, then you get an error. Because what actually happens is that the network will bounce back this connect request to you. You realize, okay, you didn't receive connect accept, in all the appropriate format. So that's the host is on the proxy server. So you have that, and as far as write goes, nothing really interesting is going on here. We're encoding any sort of if you want to write a bunch of bytes, we're encoding it in UTF-8. That's pretty standard, right? So because the idea is to work with strings everywhere, so it's easy for everyone to understand this, and releasing it to the public, you want people to be able to, who might not necessarily be experts here, just to be able to understand what's going on. It's much easier to work with strings than it is to work with a bunch of bytes, right? So yeah, and then this is kind of cool. This actually there wasn't a really easy way to do this in the STL, but converting a stream to a string, or an input stream to a string, is this, and this is like the beginning of your input. So that's kind of cool. You can see more about it at the URL here. It was great to have that little utility function, and thank you Pablo Repin for that. So, all right, let's see. So we went over the client listener thread and sender threads, which I mean, those are internal. You're not going to use those as a user. Those are internal, but they're basically the sender and receiving side, because the differences in the constructor is that you either start the receiver thread or listener thread or sender thread. Yeah, another thing is actually, so I did modify this quite a bit. It was much smaller, as you'll see here. It was much smaller from what I found it as here. But the idea is that so you're behind a NAT and you want to know what the server is going to see your IP address and port as. So how do you know what your IP address, or otherwise what your host name is going to be? You look it up. So yeah, you just look up your IP, and there you go. All right. So you use the Amazon service to do that. Doesn't take long at all, and there you go, you get it back. So how do you know what your port is going to be? Well, it's actually for most NATs, and not all NATs do this. So it doesn't work for those NATs that don't. But for the idea is that NATs should be preserving ports whenever possible, right? So this should work for the majority of cases. And by preserving ports, I mean that if on your end, your local port for your socket connection that you have should be the same when it undergoes network address translation. In other words, the IP address, you have your local IP address and your local port. When that's translated to your external IP address, by NAT, and the external port should be the same as your local port. So that's what it's using right now. That's about as good as you can do, because you can't look up what is my port, right, online or anything like that. I mean, I guess you could use like Universal Plug and Play or something, but at that point you're not covering everyone. Like, there's no way to get everything. It's just you can get better and better and more accurate, but you have to keep implementing all these new techniques, right? You need to make sure it works across platforms and all that, and that's not really what this is about. So yeah, if the ports are preserved, then it works great. And I guess the consequence of this is that it doesn't work behind double NATs either, because there's an app here. But the only thing is, if you run that app on the it's the Android app, if you run that on the Android emulator is actually also doing NAT itself. It has its own layer of NAT, right? But the Android device itself doesn't. So yeah, you can that's why I'm not demoing it here. You can receive behind double NAT. You can't send if you're behind double NAT, just because that it doesn't really work, right? Because you get the correct external IP, but that's the top level NAT. So yeah, that's pretty much it. I mean, this is what you present to the users, and there's a jar of this I used in the Android app, and Android app, it can receive and send. You receive behind end layered NATs and all that. So you can send behind one NAT. So, all right. Hope you guys liked it, and just let me know what you think.